So we have that our grams is equal to PV over RT times the molecular weight. So this is the formula that we're going to use. So um, our volume is equal to 250 milliliters, but this here has to be converted to liters because of the ideal gas law. So this has to be 0.250 liters. Our temperature is equal to 25 degrees Celsius plus the 273, which would be equal to 298 Kelvin. And then our pressure is equal to 0.350 atm. Alright, and of course our molecular weight is going to equal to 70, and that comes from the chlorine. Each chlorine is 35 and we have 2 of them, so that's 70. So we substitute everything back into the equation. We would get pressure is 0.350 times our volume, which is 0.250 times our molecular weight, which is 70, divided by our ideal gas law, which is 0.0821 times our temperature of 298. When we do our calculations, we would get 0.25 grams. This would be our final answer. Okay, take a look at another problem. It says, what is the density of CH4 gas, methane gas, at 25 degrees Celsius and 1 atmosphere? So again, we start with our equation. PV is equal to nRT. We already know that because we're looking for density, density is equal to mass over volume. So we want to find the density. So using this equation, we know that our moles is equal to grams over molecular weight. If I take the moles and substitute back into the equation, or grams of molecular weight, I will have PV is equal to grams over molecular weight times RT. And from this equation, I only want to have the grams and the volume, because that's mass over density. So I have to rearrange this equation so that I would have grams over volume would be equal to the pressure times the molecular weight divided by RT. So you can derive all of these equations generally from the gas law equation, but sometimes it's just better to memorize it. Knowing that information, then I can just substitute back into the equation. My temperature is 25 degrees Celsius plus 273 gives me 298. My pressure is equal to 1.5 atmospheres, and then my molecular weight for the methane is equal to 16. So I substitute this information back into the equation. Pressure 1.5 times 16 for the molecular weight divided by my ideal gas law. This would give me 0.0821 times my temperature, which is 298, This here would give me my answer as 0.98 grams per liter, which this is what we have for density. That is density. Density is mass over volume. Okay. Take a look at one more problem. Here we're looking at a gas has a density of 0.645 grams per liter at 65 degrees Celsius and 0.66 atmospheres. What is the molecular weight of the problem? So here we're going backwards. We already defined what density was in our last problem. So we had density was equal to grams per volume is equal to the pressure times the molecular weight over ideal gas law times T. So in this instance, we're already told density. Density is equal to 0.645, so we know what that is. And we want to solve in this equation, we want to get this variable here, molecular weight. So in order to get the molecular weight, we rearrange this equation such that molecular weight is going to be equal to G over V times RT divided by P. So we have grams over volume times RT divided by T by P. When we substitute back into the equation, we know that our density is 0.645. So this number here is 0.645. Ideal gas law is 0.0821. Our temperature is going to be 65 degrees plus 273, which is going to be equal to 338 Kelvin. So that number goes here, 338 Kelvin. And all of this here is going to be divided by our atmosphere, which is 0.886. When we do our calculations, we add this up, we will have 20.2 will be the molecular weight of the substance that we're looking at. So 20.2. Okay. I think that covers everything. I think we've pretty much done everything we need to do on this. That's a wrap.